Hey friends, we are back. It is day 2 of .NET Conf. Remember that we have 2 live streams going on right now, and tomorrow we've also got 2 streams. We've got Beginner Day tomorrow, so be sure to let people know who are learning .NET that we're going to have a whole day of 2 hours of .NET Core beginner content with myself and Kathleen Dollard. We're going to have Bill Wagner talking about C# for 2 hours, and we're going to have F# content, all for beginners. Definitely check that out tomorrow. Right now, we've got Jacob who's going to talk to us about running PHP on .NET Core with Peachpie. Peachpie is an amazing piece of technology, so if you love .NET and you love PHP, you're going to love Jacob's talk. So take it away, Jacob.
Hi, I'm Jacob. Thanks for having me here. I'd like to talk about our long-running project called Peachpie, which is a second generation of our PHP compiler to .NET. The first one was Phalange, if you know it, but this one is completely new, redesigned, new compiler of PHP for .NET platform. So I'd like to introduce the compiler just quickly, because I'd like to show you some cool samples. First of all, it's complete re-implementation of a PHP language for .NET. So you don't need some PHP runtime or anything else. It's completely managed code running your PHP application, and it's compiler, so it analyzes your code and generates real DLL files containing clean managed code, as we will see after a few minutes. The Peachpie project compiles all the re-implementation of PHP runtime and all the extensions and libraries from PHP, so you don't need them as well. And it's compatible with ASP.NET and ASP.NET Core, so it runs on Azure, IIS, and all the web servers. It runs on Linux and Mac, because it's cross-platform and managed code. And it's based on a Roslyn architecture. So if you know Roslyn and if you like its API, you can use the same API to interact with the compilation process of the PHP language. So that was the theory. We can see some diagrams in here, like we process PHP using the Roslyn algorithms and Roslyn data structures, and produces DLL, which is compatible with F#, C#, and all the other stuff. But why? Most of the people are asking why we do this, or why would they use it? Most of the users of the Peachpie compiler just want to change the platform of their PHP application to .NET, or they would like to re-implement or replace parts of their PHP programs with C#. So it's possible as well with the compiler. So you can combine your other .NET components with the PHP language seamlessly without any big overhead. You can analyze your code with Peachpie, you can diagnose performance, and you can migrate your PHP projects to a modern platform like ASP.NET Core, using Visual Studio, using new MS Build, and so on and so on. What's great about the compiler and about the Peachpie project, it's trying to be compatible with the PHP 7. So if you have an existing application for PHP 7 or PHP 5, it will eventually work on Peachpie someday. So I would like to show you some demos, because it's more interesting than this. What's cool about a compiler? It really combines all the benefits of .NET and PHP. So pretty cool use of the compiler is that you can write an application in PHP, which has some nice syntactic sugars and can be a little bit smaller than the same application in C#, and you can take advantage of existing components in the .NET. So what I would like to show you as the first as the first demo is a combination of PHP language taking advantage of the .NET. Let's start with the MS-Build project, which is quite small. Just notice it's like a normal project for a C# application. We specify the target framework for the application, which will be .NET 4.6. We will specify the output type will be exe, and the debug type is false, is full, so we will generate real PDB symbols for the PHP application. What's different is we will compile PHP files instead of CS files, and it's all possible thanks to the NuGet package specified on these two lines, where we just say, hey, we would like to import a NuGet package called Peachpie compiler tools and Peachpie SDK, and let the MS-Build to use its targets and override the compilation process with the compiler content in these two packages. So actually this one line downloads you the compiler as a NuGet package, and this line will download the runtime as a NuGet package, the complete PHP runtime implemented in .NET and C#. The third line is more exciting. You can just reference a NuGet package to your PHP application. So in this example, I will take advantage of package urho-sharp, which is Xamarin's like a game library, a 3-dimensional, 2-dimensional graphic library. And since I always liked to make games, I've decided to make a demo with 2-dimensional graphics. And it's all compatible with MS-Build and Visual Studio, so we can just load the project into Visual Studio. The project is pretty small. In addition to the reference to the urho-sharp, we have one PHP file in here. And you can see it's clean, unmodified PHP syntax, just taking advantage of .NET objects. In this case, we are just normally accessing property in PHP and changing its value using the PHP syntax, and we are accessing the .NET property, and in here we are defining an anonymous class, which you can't in C#, but you can in PHP, extending a .NET class. Normal implementation of constructor, normal overriding of methods. For example, this one. You don't see override in PHP because PHP doesn't have overrides, or PHP overrides everything by itself seamlessly. You would have to write override keyword in here in C#, but everything is smaller in PHP. So let's just compile the project and see what happened. The compilation process created an exe file, and since it's .NET and it's managed code, we can reverse engineer the file. We can take a look into the file and decompile it back to C#. That's why we are using the tool ILSpy. So let's take a look into the compiled arrow sample. And you will see it created pretty strange C# code or .NET code. It's actually something like this. So we can decompile it back to C# from PHP. We can see our class, and if you take a look on this code, you can see a little bit. Oh no, it's pretty clean C# code compiled from a PHP code. So originally it was a PHP in here, and the compiler created the same program in a .NET. Additionally, you can notice PHP doesn't have types. PHP is not type-safe language, it's dynamic language, but a compiler performs a type analysis, performs control flow analysis and inherits the types of variables and other objects. So even there is no type information in the source code, it is inherited and analyzed and created in the resulting C# code. For example, in here, the object is of strictly type resource cache, but in PHP the type is not strictly typed, so the variable is not strictly typed. So we are actually creating a type-safe alternative of the original PHP language. For example, if we change or if we add something like this in here, notice the same variable can hold two different types, and the compiler analyzes the code, notices the change, notices the difference, and creates a different. I just hit F5 to refresh the view, and you will see the cache is now a PHP value, not a strictly typed object. So the compiler analyzes the code and makes everything, I would say, type safe and as fast as possible. Even this is a dynamic language, even the PHP is dynamic language, calls to methods are direct. It's the same as you would write a dynamic in C#. The C# compiler would create call sites everywhere, which have a little bit overhead. The compiler of the PHP language is trying to not create call sites everywhere, to not behave dynamically if it's not necessary. Let's run the code so you can see it's actually doing something. Just hitting F5. Notice we have placed a breakpoint in here. It just stopped. And this is the first cool view on a running PHP application, actually. On the right side, you can see diagnostics. You can see .NET diagnostics of a PHP application. On the bottom, you can see locals of PHP program. It's all taking advantage of a .NET debugger, but you are debugging PHP language. So now I'm just hitting F10 to step over lines. You can see variables are changing. The .NET call stack, which is representing the PHP code. Values of variables. Everything as you are used to from C#, for example, but it's actually a PHP language. So I just continue running the program, and here's the result. Here's an implementation of a two-dimensional window using accelerated two-dimensional graphic programmed in PHP language. So this is just first demo of possibilities of how you can extend a .NET library with a PHP code, of how you can extend a library that is targeting Windows, Linux, Mac, and Android and iOS. We actually didn't try the Android and iOS, but I'm sure he will try it maybe. So let us know, I guess. But that's one possibility of the PHP compiler for now. So that was the first demonstration. As the second one, this one was the quick one. As the second one, I would like to show you some big application, something, some legacy big code, large code base. You would like to migrate, transfer to .NET, and take advantage of the .NET. And I would like to show you some of these advantages of running an existing PHP application to a .NET. For this part, actually a few days ago, we have started working on MediaWiki, which is a huge project. It's one of the biggest projects we've tried so far. So it's not running completely, but I can show you the compiled code. I can show you how you compile it in command line, and as a first use case of existing website in PHP running on the old IIS or on the old Internet Information Services web server before we try the ASP.NET Core. So for this part, I've prepared in my Internet Information Services console a MediaWiki website, and I've created a new project file. This one. And this is the project file describing the web application. So this is all I need to compile the whole website to a single DLL file. Notice we are specifying all the PHP files will be compiled, the same compiler tools package as before, the same SDK containing the runtime, and additional package is a request handler that implements request handling for ASP.NET. So it's not ASP.NET Core yet, but it's for the old ASP.NET. Also, we have a configuration file for the ASP.NET. The only thing we have to specify is the PHP handler for PHP files. So this piece of code tells the Internet Information Services to handle PHP files with our implementation of request handler, and the request handler loads compiled DLL file of the PHP website and calls specific compiled code, as we will see later. So how does it work? In here I'm on the command line, and I can just specify to restore my project. So all the dependent libraries, our SDK and our compiler is downloaded, and so I can continue by building the website, just like that. This process takes a little bit longer. The project is really huge. It's like thousands of files, so it takes some time. First of all the source files are parsed and analyzed. All the potential issues are found. So if you're running a huge application, you can just use this part of the compilation process to diagnose your code, to find out possible issues. In case of this project, there is like thousands of them, so don't be scared about outputs of the compiler, but most of them are really useful. For example, we are analyzing code that's unreachable, like C#. We are analyzing code that's potentially dangerous, like use of eval. We are analyzing code that is potentially not working, like assigning different types to a variable that shouldn't hold it. So if you specify in PHP type of your function return value and you are using it for something else, it will warn you. It's also propagating constants, so it's optimizing your code. It's generating something that should be more performant than before, but just note it's not the final stage of the product, so there's still a lot of space for optimizations. Now you can see all the warnings from the compilation process. The nice one is the call to undefined function and or use of undefined variable. It's pretty frequent in PHP and it's really dangerous. So you can check this before running the program actually, and you can see it using the compilation process. This one is really interesting. This one is interesting because this is actually bug in MediaWiki and in Wikipedia actually. In this file, they are using a type that doesn't exist, so this might be an issue, and this will crash in runtime if they will run it. So we should probably report it to MediaWiki. Now the code is analyzed and parsed, and the compiler is generating the DLL file. It takes some time because it also generates XML documentation files and debug information files, and it's like 30 or 40 megabytes of data. But notice I'm running all the debug versions of the compiler, so it's a little bit slower in here. It should be in every minute. Meantime, we can take on to the result of the compilation process. It's a mediawiki.dll file. What's interesting is all the classes compiled in the resulting code. So this is whole MediaWiki compiled into a single DLL file. Actually, it means you won't need source files if you distribute this DLL file. You can compile your PHP project and distribute it without the source files, because all the files are compiled into this single DLL file. So let's take a look first on some compiled classes. For example, I don't know this one. It's category page, good. First notice there are XML comments. So the parser, the compiler analyzes and parses the PHP comments from the code and generates corresponding XML documentation comments. So then if you decompile the code, or if you use the code from your C# application, for example, as we will see later, you will see these comments in the IntelliSense. And here is some, okay, like this one. This one is better. Here is a compiled PHP code in the C#, as we saw before. There are also a bunch of weird namespaces. It's actually compiled files containing main, which means a global code. So in this way, the runtime recognizes compiled files and finds out methods corresponding to a source file. Then if the request handler from the ASP.NET tries to request a file, it finds out this class and just calls this main method, which just declares some types, and so on. I will describe it in more details because it's described on our wiki on the GitHub. Anyway, it's compiled, and yes, I have it running in here. It's a regular website configured on as an ASP.NET website. But what's great, I can now attach to the process. In this case, it's called like W3VP, yes, this one. And now I'm attaching compiled PHP website using the .NET debugger and .NET diagnostic tools. Now you can see process memory, CPU usage, and everything else, exceptions, garbage collection, and so on and so on. If I refresh the page, I can see it's doing something. So now I can dive deep into the running process, analyze the CPU, and use my favorite profiling tool like this one to find out why is it so slow. So this is nice. I can see a PHP code running as a .NET application with all advantages. Here I can take advantage also with memory usage profiling, so I can take snapshots of the memory and find out why it's taking so much memory, and so on and so on. In this case, it's using like 400 megabytes of memory, but it's running as a debug, so in release it's much smaller and a little bit faster as well. So that's it. That's running a bigger site using a Peachpie. There's no PHP runtime and so on. Since MediaWiki is not running yet completely, I will rather show you a different project we have shown before. It's a WordPress site running on a .NET. So we've did the same process as with the MediaWiki. We've compiled the WordPress into a single DLL. And this is the result. It's called website, or not. So again, we have all the PHP classes compiled to .NET classes in a single DLL file with all the PHP commands and all the names of functions and everything else. So it's ready to be integrated into a bigger .NET application. Like, let's say there's a request, yes. So yes, you will see a C# alternative of the original PHP code. We can do the same with the WordPress as we did with MediaWiki. You can attach to the process, analyze it. You can see the CPU usage in here. You can see the memory profiling, and it's running in the same application pool, so we are already attached to the process and diagnosing it. Here, it's all orange because we are running on Peachpie, right? So this is the complete WordPress running on a .NET because it was compiled as a .NET application and it doesn't need any PHP. Why would we do it? Why would we change the runtime and run it on .NET instead of PHP? Well, the first great advantage is the tooling. Visual Studio is great piece of software that gives us a lot of possibilities of analyzing the code, finding issues, optimizing the code, and so on. So these diagnostic tools are now available to a PHP application. That's the first great use case. The second one, we can fully take advantage of Azure and other strictly .NET platforms, strictly .NET host providers. That's the other one. And of course, the performance, the compilation process should generate a more performant code than before. Then instead of interpreting the PHP code uses PHP interpreter, we can compile the code and take advantage of .NET just-in-time compiler and maybe .NET native. So we can possibly in the future compile a PHP application to a native application optimized for your current platform. And another advantage would be we can run on any other platform. The compiler generates managed code, which is cross-platform. It's running everywhere where we can run a .NET or .NET Core. So all the Android, iOS, Mac, Linux, and Windows platforms should be supported within one compiler with one generated DLL file. And the greatest advantage is the interoperability with existing .NET or C# applications. So since we have these compiled classes and .NET methods generated from a PHP code, we can use them, of course, from your C# application. And moreover, we can replace them with a C# application. So if you are optimizing your PHP web, for example, you can find out using the diagnostic tools there is something slow, you can just remove it from PHP and implement it in C#, as we show just after a few minutes. As I mentioned before, you can target the compiled website as an ASP.NET or ASP.NET Core application. So to show you the ASP.NET Core application using the Kestrel web server, which should be slightly faster than the IIS, I have prepared a WordPress site using the Kestrel web server, which is the ASP.NET Core web server implementation. First, let me stop this old IIS server, just like that. So now this one should not work anymore. Yes, it's that. Good. And here I have a web server called Kestrel. It's a Microsoft implementation of ASP.NET Core host. So it's absolutely normal piece of code you will find on the website used for your ASP.NET Core websites, with a one additional piece of code. It's this one. In here, I add a request handler for PHP to the application builder, to the pipeline, and I say, let's use this compiled assembly, this website DLL, and use scripts compiled in this site to handle PHP files. So this is the only line I have to add to my Kestrel web server. So it will handle the request to PHP files and pass them to the compiled assembly, to this one. So if the handler gets a request for an index PHP file, it finds out this sealed class and just invokes this main method representing global code of index PHP file. That's all. So it's a middleware for ASP.NET Core, connecting ASP.NET Core with compiled PHP code. So how to do it to make it working on single .NET run command. The project contains a reference. The web server contains a reference to my website project, which is here. And the website project is our PHP project file, not targeting net 4.6, but targeting net standard 1.6. It's okay, I guess. And we don't need this ASP.NET request handler, because now we will be using this package for the ASP.NET Core. So this package contains our middleware for ASP.NET Core, and that's pretty it, I guess. In here, yes, net 1.6 and referencing the OLE SDKs. So now I have to open a terminal and just restore the packages. Where's the terminal? Where is the terminal? Guess this one. Let me restore the packages first, because I've changed the target framework, so it needs some restore. And that's it. Cool. Then just put some breakpoint in the index. It's already in here. Notice I don't have any extension for PHP language. It's all .NET. So the only extension in VS Code I have is our Peachpie extension, which does the only thing. It provides me the problems of the website from the diagnostics, and it allows me to put breakpoints in PHP code. So if you would like to use VS Code, just install this extension and you will have all the benefits. Okay, that's it. It's restored, and now I just hit F5. F5, yes. Oh, that's it. So, yep, our application has started. The Kestrel web server has started, and yeah, let's just change the port number to something else, because 505. Just recompile the project to reflect the changes. And now after compilation, we will be running the Kestrel web server, the ASP.NET Core web server. running a PHP application compiled to a .NET. And let's see the other advantages of this one. Again, it takes a little bit longer because we are running debug. Also, we will see a bunch of warnings from the WordPress site. Some of them are really important because there are bugs in the WordPress, and the compiler just finds them. And that's it. Now it's compiling the web server. Cool. It's starting, okay. Now it's running on the good port. So now we are running the Castro web server, and we can hit refresh. Hit refresh. You can see it hits our breakpoint. Again, debugging the .NET application, which is actually PHP. This is a little bit different than before, because we are not debugging .NET Framework, full .NET Framework program. We are debugging .NET Core application. It has a different PDB files, different debug information files, and different runtime, completely different runtime. Now we are running on .NET Core instead of .NET. So this one is really portable. It will run in the same way on Linux and Mac and anywhere else where I don't know where it can. Now I can use all the debugging commands as I'm used to, like F11 to step into, F10, and of course watching the variables. What is interesting is the locals in here. As you can see, I'm in global code in PHP, which is something that doesn't exist in .NET. So this is actually something like this. It's compiled as a method in a special class. And you can see very weird names of variables using these brackets. We choose to use variables like that, so they will not interfere with normal variables. And also you can see all the global variables in PHP are represented as an array. They are not local variables, but if I step into a function, now I have real local variables. So as I'm debugging the code, I can see real local variables representing the PHP objects, like in here. Notice I'm still using the .NET debugger to debug my PHP application, which is great. So we didn't have to write any piece of code to make this happen. It's pretty cool. And so on and so on. We also, we should see it after a while. If you jump into the dashboard of the WordPress, yes, cool. It's all the same. So that's a bigger legacy code running on .NET as compiled from PHP code. And now if we have all of this, we can just combine it all together and interoperate, combine the C# code and the PHP code in a one single application. Let's just stop this one. And I have prepared the demonstration of hybrid. Yes, that's it. It's called hybrid. I've prepared a demonstration where we have a PHP library consisting of a few files, like this one. We have a PHP class called user, and the PHP class doesn't use any advantages of the C#, but we have commented out one function, and we will implement it really dynamically in a C#. So in C# we have created, for example, a superclass of the user. So we are inheriting a user class from PHP as a C# class, and also we are implementing, or we are injecting into the runtime of PHP and improving it with a C#. So I just hit start to start debugging. Oh, okay, whatever. I would like to hit start. Yep. Now I hit start. Compiling, still compiling. Interesting. Let's just build it in terminal. Oh, it's still compiling, okay. Now it's running. So we are running a C# application, and what we did here, we have manually created a host context for a PHP program. We have loaded the compiled PHP program into the context, and we are playing with it. So we are dynamically declared a function, a PHP function, and instead of calling the original PHP code, we are calling a lambda function in C#. So we have a breakpoint in here to see when it happens. Also, we can dynamically create a PHP class called user, and if I hit F5, you will see it stops at the breakpoint in the PHP code. So if you see a call stack in here, we are here in a C#, and now we are here in a PHP. So we are really compiling two different languages into the one, and none of them takes care about the other one. It all behaves like it wouldn't be there. Cool. Now it calls the PHP call, PHP function call, implemented in a C# as a lambda function. It's pretty cool. Here we can see locals and the debug information, etc., etc. It's authorizing. Now we have created an inherited class in C#, inheriting from a PHP class. So now we are really mixing these two words together, because yeah, this one is great. We are in PHP, then in a C# constructor, then in a PHP constructor, and seamlessly back in a C#. So in this way, we can create a hybrid of these two languages altogether and take the best of both worlds. For example, you can, in the same way, you can use NuGet packages and use them in a PHP code, or you can create NuGet packages from a PHP code and use these NuGet packages in C#, and so on and so on. So this is the final hybrid I'd like to show you today. And that's it. That's pretty everything. I hope you enjoyed the last demo, last example. And that's all. That's all from me today. So if you'd like to see more about the project, you are interested, just follow the GitHub, github.com/pchp compiler/Peachpie, or our Twitter or Facebook, or go to our website peachpie.io, where you can see all the other blog posts and information about the project. So yes, that's it. So if you have any questions for me now, I'll be pretty happy to answer.
All right.
All right.
Fantastic. Got a couple questions here. One person was wanting to understand how the third-party modules show up into a compiled WordPress application, that relationship between the WordPress app that gets compiled and then the third-party module that you would compile.
Third-party module, what do you mean?
Like if someone wants to bring in a WordPress plugin.
Yes. You can just copy the plugin into the directory of the WordPress. I'm not sure where's the WordPress here. So the plugins in WordPress are in a folder like WP Content plugins. I have one here. It gets compiled together with the WordPress. So you just copy the plugin into the folder as you are used to, and recompile the project, and the plugin just pops up in there. The only thing you have to know is WordPress is file system based, so it touches files on your physical hard drive. So you can't have just the compiled DLL for your website. You have to keep the sources of plugins into the website root as well. So the WordPress architecture, the WordPress code itself finds the file and loads the compiled classes as it should. So just like that, you just copy the plugin into the file directory and recompile it, and it should work. That's it.
Cool. So that sounds pretty straightforward. And would someone want, maybe this is a dumb question, forgive me, but would I ever want to write a plugin for a PHP app and write it in .NET proper, write it in C#, or would I always want to write it in PHP and then let Peachpie compile it?
Yes. Actually, since for Peachpie, PHP and C# are the same, so all the extensions for written for the Peachpie project are in C#, so you can write C# extension, or you can use PHP to write extensions. So it's up to you, actually. In case of legacy PHP, you had to write plugins, you had to write extensions in C language, which causes a lot of troubles. In case of Peachpie, you can write extensions in C#, which is much better and faster. That's why we achieved to implement most of the PHP functionality so fast, because it's in C# and it's just really easier to implement most of the functionality in C# than in plain C. So yes, you can write extensions in C#, or you can write them in PHP and compile them to DLL. It actually doesn't matter. On our wiki page on GitHub, we have a description how the extension to the Peachpie runtime looks like, so you can take advantage of all the features the runtime offers you. So just go there and you can see the architecture of extensions. I can show you maybe. Yes. Yeah, that's a great question, actually, because we are just a few guys running this project, and what would be really great is try smaller applications, try just small pieces of PHP code, and report issues. That's the first thing you can do for us. Just try some legacy PHP code and report there is some function missing, some class missing, there is something behaving differently in PHP and in C#. Smaller the test case is, it's better. Another thing you can do for us is just spread the word and tell the other guys to try it, because it's just cool. Or for example, if you are interested in the first example I showed you, it would be really great to try to develop an application in PHP and run it on Android or iOS or Windows Phone device. It would be really cool to use Xamarin SDK and run the PHP application on a mobile phone, which should be possible. So all the amazing, cool test cases we could try would be great, and share the result with us.
Very cool. Well, thank you so much for your time and for spending your day with us here at .NET Conf.
Yeah, thank you too. It was amazing to be here.
And this is remember, this is live, but this is also going to be recorded and available, so you can learn about Peachpie. If you just joined, you can go back and watch this later. Remember also that tomorrow we're going to have 2 tracks, just like we have today. One of the tracks tomorrow is Beginner Day, so be sure to tell the beginners in your life, the people doing code camps and boot camps, that they can learn all about .NET, C# and F# tomorrow. But stick with us. We're going to take a short break, and we'll come back with even more great content here at .NET Conf 2017.